Hello, so in this video we're going to look at chapter 6.1, greatest common factor and factor by grouping. So in this video we will look at the 4 distinct topics, and in the description below there will be video chapters so you can jump to certain sections that you would like to see. There will be a link to the first and second edition of the Openstax Intermediate Algebra textbook. There'll be a link to a shoulder folder with more notes and handouts and examples that you're welcome to look at and view. At the bottom there will be a survey that I appreciate the feedback and that you're welcome to do. So first, we're going to look at the greatest common factor. And typically, when we're given a number, we will take the number and put it in lowest terms. So we would put it like 2, we would put 2 to the third power times 4, or whatever the prime factorization for that given number would be. So let's look at some examples. So we are given 28x squared y to the 4th and 42x to the 4th y to the 4th. And we want to figure out what's in common with those two that we could factor out if need be. So if we look at 28x squared y to the 4th, we know that for 28 we would have 2 times 2 times 7 times 2 x's and 4 y's. And for 42 x4 y to the 4th, we would have 2 times 3 times 7 times 4 x's times 4 y's. And so we can see anything that is in common with both of them, you would bring down as a common factor. So we can see that we have 2's in common, we can see that we have a 7 in common, we have 2 x's, and all 4 y's are in common. So for our greatest common factor, we would bring down a 2 times 7 times 2 x's and 4 y's, and our greatest common factor would be 14x squared y to the 4th. For the next one, we have 45a squared b cubed and 18a to the 4th b. And so we want to do the same thing that we did in the first one and list it out and find out what's in common, bring it down, and that would tell us what our greatest common factor between those two terms would be. So for 45a squared b cubed, we would have 3 times 3 times 5 times 2a's times 3b's. And for 18a to the 4th b, we would have 3 times 3 times 2 times 4a's and 1b. So if we bring down what's in common, we can see that we have 2 3's in common, we have 2 a's in common, and we would only have 1 b in common. And so our greatest common factor would be 3 times 3 times 2 a's times b. So our greatest common factor would be 9a squared b. So next we have the distributive property. And with the distributive property, we are taking a binomial and we're trying to FOIL it into 2 binomials. So if we're given something like a plus b and c plus d, we're subtracting the a times c, a times d. And then we're also going to do b times c, b times d. And then we're also going to look at where we have a case where we have something like ab plus ac, and we want to pull out what's in common, and we can see that we have an a in common, so our answer would be a b plus c, where we're factoring out from that polynomial or that binomial. So let's look at foiling. So we're given in the first one m plus 4 in parentheses, m plus 12 in parentheses. And so if we do the first one, m times m gives us m squared, m times 12 gives us positive 12m, 4 times m gives us plus 4m, and 4 times 12 would give us a positive 48. If we combine like terms, we would get m squared plus 16m plus 48. So we are given 2x minus 3 in parentheses and x plus 6 in parentheses. If we look at FOILing, we would do 2x times x would give us a 2x squared. We would do 2x times 6 would give us a positive 12x. A negative 3 times x would give us a minus 3x. And negative 3 times 6 would give us a negative 18. If we combine like terms again, we would get 2x squared plus 9x minus 18. So now we're going to look at factoring out the greatest common factor within a polynomial. And if you remember from the last section, I was talking about how if we had something like a b plus a c, we would factor out an a because that's what's in common between both terms. So we would have an a and then a b plus c left over. And so that's the idea of what we're going to be doing. So for the first one, we can see that we have an 8m squared minus 40m plus 16. And we can see that we have a 8 in common for each of those, and so that would be our greatest common factor. So if we pull out an 8, we're left over with an m squared minus 5m plus 2. For the next one, we have 24y cubed minus 18y squared minus 30y. And we can see in this one that we have a 6 in common, and we also have a y in common. So if we pull out a 6y, we're left over with a 4y squared minus 3y minus 5. So next, we're given 21pq squared plus 35p squared q squared minus 28q cubed. And so we want to pull out what's in common within the numbers and the variables. So we can see that if we have a 7 in common, and we also have a q squared in common. So if we pull out a 7q squared, we would have 3p plus 5q squared minus 4q. And so if we arrange, we could write our answer as 7q squared in parentheses 5q squared minus 3p minus 4q. And so if we wanted to also check our work, we could also take what answer we find, so 7q squared, and in parentheses 5q squared minus 3p minus 4q. We could take whatever we found and distribute it inside our parentheses, and we should get back to the original equation that we were given. So next we're given negative 32m to the fourth n squared plus 14mn cubed. And so we can see that if we pull out a 2mn squared, that's what's in common with both of them. And so if we pull out a 2mn squared, we're going to be left with negative 16m cubed plus 7n. So next, we're going to factor by grouping, and typically it would be 4 terms, and you would find out what's in common with the first two, what's in common with the next two, and then that would be your binomial. So in this first one, we have mn plus 7n minus m minus 7. And so we can see that we have our first two, and we have our next two. And so if we pull out what's in common with the first two, we can pull out a n, and we would be left with an m plus 7. And if we want this m plus 7 to come back, we would need to pull out a negative 1, and we would have an m plus 7. And our answer would be n minus 1, m plus 7. So next we have 6x squared minus 3x minus 4x plus 2. And so we can see that we have our first two and our second two. And in the first two, we can see that we have a 3x in common. Pulling out a 3x from 6x squared, we will be left with a 2x. And we would just get a minus 1 back. And then to see what's in common with this next set, and we want this 2x minus 1 to come back, we could pull out a negative 2, and we would have a 2x minus 1 coming back. And our answer would be 3x minus 2, 2x minus 1. So next we are given 4x squared minus 36x minus 3x plus 27. And so we can see that we have our first two and our next two. And if we want to find out what's in common with the first two, we can pull out a 4x, and we're left with x minus 9. And since we want this x minus 9 to come back, we can pull out a negative 3, and we would have an x minus 9 back, and our answer would be 4x minus 3, x minus 9. In the second one, we have 5x cubed minus 3x squared plus 5x minus 3. And so since we know that we have our first two and our second two, we know in the first two we have an x squared in common. Pulling out an x squared, we would have a 5x minus 3. And since we want this 5x minus 3 to come back, we can see that we just pull out a positive 1 that will come back. And our answer would be x squared plus 1, 5x minus 3. And to check your answer, you could take the x squared plus 1 and the 5x minus 3 in FOIL. So we would take the first and the second, and then do the inner first and second, and that should, when you combine like terms, get you back to your original equation.